Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video, and today we will go through solving equations that have fractions and brackets. So let's start with fractions. Now you don't need to worry too much about these types of questions because, a fraction just means to divide anyway. So let's look at a couple of equations. So I've put two equations on your screen. The way that we're going to solve them is exactly the same way we solved them last year, and indeed any time you've had to solve equations. What we're going to do is undo everything that's been done to our unknown number x and do that in the opposite order to BODMAS. But firstly, what's the difference between these two equations that you see on the screen? Are they exactly the same? Well, they're definitely not, because they actually have a different answer, as you will see. So why are they different? How do we solve them differently? Well, if you look at the first equation, what we've done is we've taken our unknown number x, we've subtracted 3, then divided by 9. In this equation, the second one, we've divided by 9 first and then subtracted 3. So the only difference between these two equations is order of operations. So when we're solving it, we're going to perform the same operations but in a different order. So it's really important that when you're solving equations, you do things in the correct order, the opposite order to BODMAS. Now please note, these fraction lines just mean divide. So we can undo them by multiplying. So in the first one, as I said, what we've done is we've taken x, then we subtracted 3 from this unknown number, then we divided by 9, and we ended up with an answer of 1. So if I want to solve it, I'm going to start at my answer. So instead of dividing by 9, I'm going to times by 9, which obviously 1 times 9 is 9. And then instead of subtracting 3, I'm going to add 3. And 9 plus 3 gives you 12. So the answer to this first equation is x equals 12. So note, this fraction line here meaning divide, I divided by 9. To undo that, I just times by 9. So remember, fraction line means divide. Let's have a look at the second one. Let's go and solve it. So I took my unknown number, but this time I divided by 9 first. Then I subtracted 3 to give me my answer of 1. So if I want to find what number I started with, what x is, I start at my answer of 1. Instead of subtracting 3, I add 3. And then instead of dividing by 9, again I times by 9. So you can see that there are the same boxes. There's a times by 9 box and an add 3 box. The difference is the order. This time I take 1, I add 3 first to get 4, then I times by 9 to get 36. So the answer to the second equation is x equals 36. So they're different equations and have totally different solution merely because of the order of operations. So don't be freaked out when you see brackets, because they only mean to divide. Now we're going to do some harder ones with fractions. So what if I have something like this? X over 2 plus x over 3 equals 32. So this one's a little different from the previous questions, and that's because x is now in more than one spot. The unknown number isn't just in one place. So when that happens, we need to first get the pronumeral into one spot. So you know how to add together these algebraic fractions. We did it in the algebra section earlier this year. So you treat them like you would normal fractions. So remember, to add normal fractions, the denominators must be the same. So what I do is I times top and bottom of each fraction by the denominator of the other fraction. That'll allow them to have the same denominator. So the first equation becomes 3x over 6. The second one, 2x over 6. X is still in one spot, but if I add together these fractions, remember I just add the tops and keep the bottom the same. Now they have the same denominator. Now x is in just one spot, and I can solve using the exact same principles I've been going through. So what I've done here is I've taken my unknown number, I've times it by 5, then divided by 6 to get 32. So I've got to undo things in the opposite order. So first thing I'm going to do is times each side by 6. Remember, what you do to one side of the equation, you have to do to the other. So times 6 and divide by 6 cancel each other out. When you times a fraction by a whole number, you don't times the top and bottom of the fraction by that number. So the 6's just go away. On the left-hand side, I'm left with 5x equals 32 times by 6, which is 192. Now, if I want to find what x is, I need to undo timesing by 5, because this is a times 5. So I divide each side by 5. So x is 192 divided by 5, which is 38.4. Please understand, the answer that you get to an equation does not have to be a whole number, nor does it have to be a positive number. So this is my final answer. And you can check that, because 38.4 divided by 2 plus 38.4 divided by 3, put that on your calculator, you end up getting 32. Okay, so I know my answer is correct. Now we're going to look at equations with brackets. So what's the difference between these two equations that are appearing on your screen? Again, the answer is order of operations. And because the order of operations is different in each of these equations, it means they'll have a different solution. So we already know how to solve the first one. It's not that hard. So what we do is we subtract 5 from both sides to undo adding 5. So we're left with 2x equals 19. Then we have to undo timesing by 2 by dividing each side by 2. And I get x equals 9.5, right? The second one though, I didn't take x and times by 2 first. I took x, added 5 first, then times my answer by 2. So when I'm solving, because timesing by 2 is the last thing I did to x, I need to undo that first. So to solve it, I need to divide by 2 first. So I get x plus 5 equals 24 divided by 2, which is 12. Because times 2 and divide 2 cancel each other out. Then, the way I undo adding 5, I subtract 5. And I get x equals 7. So even though these equations are very similar, the order of operations being different means that they have a totally different solution. Now, sometimes you'll have no choice but to expand the brackets, and I'll show you an example of that now. So let's have a go at this equation here. Now, again, we have x in more than one spot. So in order to solve, in order to use the principle of undoing what's been done to x and thereby solving, we need to first get x to one spot. You have no choice but to expand the brackets to do this. So it's important that you remember, we did this early in the year in our algebra topic. So remember, we distribute the thing outside the brackets to everything inside the brackets. So this will become 2 times x, which is 2x, plus 2 times 5, which is 10. Let's do the second bracket. So this isn't a 3 outside the brackets, it's a minus 3. So we distribute minus 3 to the 2x. Minus 3 times 2x is minus 6x. And then minus 3 times minus 1 gives you positive 3. Remember, minus times a minus is positive. And that still equals 35. We haven't done anything to the right-hand side. Now what we need to do is get x to one spot by collecting like terms. Remember, you can only add or subtract terms if they are like terms. And you can only do this, they're only like terms if they have the same sequence of pronumerals. So 2x and minus 6x, they're like terms because they both have one and only one x. 2 minus 6 is minus 4. So 2x minus 6x is minus 4x. We can't add that to 10 because 10 is another term, but it doesn't have an x. It's not a like term. But 10 and 3 are like terms. Positive 10 plus 3 is just plus 13. So I've got minus 4x plus 13 equals 35. So you know how to solve this. We've done all the hard work. I need to undo what's been done to x. So I've times x by minus 4, then added 13. There are no brackets in this equation, so I've done the multiplication first. So to solve, I'm going to subtract 13 from both sides, and I get minus 4x equals 22. And then I want to get x by itself. So I don't divide by 4 because x has been times by negative 4. So I need to divide each side by negative 4. So x is 22 divided by negative 4, which is negative 5.5. So note that our solution neither has to be positive nor does it have to be a whole number. This is the solution because if I substitute x for minus 5.5 here and here, I get a true statement. I get 2 times negative 0.5 minus 3 times minus 12 equals 35, and that's true. Minus 1 plus 36 equals 35. That's true. That's my answer. So remember, if x is in more than one spot, you must first get it to one spot. All right, this has been the luckiest maths teacher in the world. Have a great day.